Welcome to Parents' Night. Thank you so much for joining me. Let me give you a little taste of what we do in physics and astronomy class. Now, I can't invite you into my actual classroom, but I would like to welcome you to my virtual classroom. And this is actually just virtually me. I don't really look like that. I look like this. And these were more social times. It's a prom, fun, and now we have social distancing. And things are a little different.
Go ahead. You can try it again.
I don't know about you, but I feel like that little girl a lot right now, and so do our kids. But I remind them and myself that we have to be positive and patient with ourselves. We can do this. We've got this. We have ways around this. We did this during the spring. When we had to go home, we got resourceful, and I went out in the driveway and I found my biggest chalkboard ever, and we had to figure out new ways to share information. We figured out new ways to do some labs. Lab work is incredibly important in physics and astronomy and meteorology. And when you can't be there in person for a hands on lab, there are simulations you can find that can model some of the events that we needed to study. Now, happily, we're back together. And now our kids are actually doing inquiry based labs where we come up with the procedures together to develop equations that we need to study physics and astronomy.
Okay, Zach, we are going to let this little fan cart go under the influence of 4 batteries, and we're going to find the acceleration by looking at the slope of a velocity graph.
Now, you see here we have some motion sensors, and there's actually a force sensor at work in this lab as well. We are delighted to have access to sensors like that that let us get lots of quantitative data, and we use that to develop our ideas. Here's an example. We have a number of weather sensors that we use in the meteorology class. One time last fall, we got in some vans, and as we changed our altitude, we saw changes in barometric pressure and temperature. So, a very quantitative, authentic experience brought to us by our sensors. Another thing that we get to do, this one's from physics, is analyze video. So, here we have a video of a super ball bouncing, and we got to see the energy transforming from one type to another throughout each bounce. Now, it's not all technology. Sometimes it's really fun to go ahead and do a hands on, old fashioned art project. So, my astronomy kids did profiles of different cultures and what they learned in astronomy. And we like to build things too. They build spacecrafts, actual models to scale of real spacecraft. So, we try to get a mix. Sometimes we can be creative in other ways that might involve music.
Right? Can you guys see here? Yes. Okay. That's okay. Go ahead. Yes, it is.
Now, we do other creative things too. One year after the AP test, my kids did some experimentation with light painting and lasers. And here they are again in a musical selection using the same physics as the drinking straws. And anything we can do to build that enthusiasm is really, really important. Also, we need a little context. It's not just the concepts straight out of a textbook. I try my very best to show the kids why this matters, why or how these things show up in real life. So we do studies of different themes. One theme is material science. And in material science, you can learn about carbon nanotubes and how they can be used to make all kinds of exotic substances like Vantablack that absorbs almost all of the light that strikes it. We also learn about something called ferrofluid, which has technical applications, but some of the art applications are the most fascinating, like this one that you see with just ferrofluid and a little bit of paint. The material science unit is extensive, but then we get to one of my favorites, and that is space. Of course, our astronomy class spends a whole marking period on space, everything from the aurora and its causes to gravitational lensing to orbit. In this beautiful picture from our space station. All of the telescopes that are available now are stunning, and the views that we can get, these are views of our galaxy in multiple different wavelengths. So when we look at astronomy, some of it is so breathtaking, and I try to make sure that we build that sense of awe and wonder to see how physics plays a role in our solar system and universe. So the scales are kind of staggering, everything from our neighborhood to very exotic distant things like gas clouds that glow. Here's something a little closer to home. Remember Hot Wheels? We talk about circular motion and vertical circles. And we talk about what might happen if you were in a plane that started to go into essentially free fall. And we talk about things that are sturdier, like architecture, as in Roman arches, and how they might be different than Gothic vaults. We talk about modern architecture and even more modern architecture and all of the different ways that you can creatively build spaces for people to inhabit. We talk about driving. I try to make sure that the kids know that every physics student must know that seatbelts are key. Inertia is so important to what we study. And we talk about stopping distances and distracted driving and reaction times. We talk about what happens inside the car so that they can be educated drivers. We also talk about automation, and we have a number of different videos that we watch. This is a warehouse. We talk about those cutting edge developments and what role physics would play in the sensors and the math behind the entire warehouse. We talk about automation in a drone context, whether it might be one that flies or one that walks like a dog. And we talk about very simple machines and very, very complex machines, whether they're musical instruments or a car. Now, toward the end of the course, we get to do waves, and that would include the sound and light. And here we have a microscopic view of butterfly wing scales and something called thin film interference. Here we have something called diffraction, light going through this bundle of nanotubes, and they're so very small that the light itself diffracts on its way through. And we talk about sound and guitar strings and some sound that's a little bit more complex in 2D, 3D objects like these Chladni plates. It really is fascinating. We talk about electricity and how to generate it and what renewable electricity can do for us. Basically, we need to give the kids a new way to see the world, to see some things that might be hidden and fascinating, and to build that sense of awe, to make them problem solvers, and to make them not afraid to try new things and look at things in new ways. Thank you so much for joining me tonight. If you ever have any questions, please don't hesitate to email me, kfedder, Fedder, at cocalico.org, and I will get back to you as soon as I can to see if I can help. If your student seems to be having trouble with our hybrid model, please let me know. We can make sure that they know exactly what to do and we can pace it properly for them using Schoology. Thanks again for coming tonight. I really appreciate your help with your students' education and all your support. Thank you.